Let me just show my face for a little bit. So today we'll talk about Spring Test Framework. My name is Szymon Micek, and I will conduct this presentation for you. Yeah, so let's go to the presentation. So let's start with the agenda. So we'll talk first about a little bit about Netcompany. Then we'll move to the motivation behind this presentation. So why I decided to actually do this presentation, and then we'll talk a little bit about unit testing and integration testing and how actually it looks like from the Spring perspective, why they are actually create this Spring test framework, and why it is important to do some testing with Spring test framework, not just pure unit testing. And then I will introduce you the framework, the key concept like caching, context management, and configuration. So I will first start with the internal workings of the Spring, and then we'll move through annotation which you can use, or support classes which you can use in your test, so that you can conduct your test with best practices or the best approach to do this when you work with Spring. We'll talk about, and I will show you a little bit about debugging the Spring test framework, or how to see if there are any problems, or how to add some listeners or your piece of code to this framework. And then we of course will go through some examples which will also include database and MVC use cases. Yeah, so first maybe I will tell a little bit more about myself. So I'm working in Netcompany for like 4 years, and currently I have a position of master, which is person which tends to be more technical than the management guy. I also before Netcompany, I mostly works in the companies which do projects for public and private clients, and they was most related to document management or content management systems like Alfresco or Documentum. But anyway, most of my professional life, I work with Java, with Spring, with Hibernate, and all that related technologies. So I have a good knowledge and experience in that, in using that. Okay, so about the Netcompany. So the Netcompany tends to be the fastest growing and most successful IT company in Nordics, and we'd like to talk about it as much as possible, because we really gain real momentum for a couple of the last years, and we have nice and good project base which we are proud of. And of course we try to become a Northern European market leader. The Netcompany was founded almost like 20 years ago, and for the couple of years we have a very good average revenue growth. And as you can see, we also grows very much, because when I started to work in Netcompany, I think we were only in 2 countries, in Denmark and Warsaw, and right now we are in 6 countries, or I think it's even more right now. And we have more than 2,500 employees right now. And one of the things which actually makes as good what we are doing in the Netcompany is that we have this saying that IT people leading IT people. So in Netcompany is kind of true because all managers, almost all employees in Netcompany have a very good experience in IT, and they have really good background in technical stuff. So whenever you meet a manager or consultant, they will have this knowledge, and they will know what to do and how to delegate this stuff. So there is no people which just sells the stuff or just manage things. They are programmers, developers, and they have technical knowledge, and this is something which we are really care about in Netcompany. So and it is very important for us. Okay, so moving forward to the motivation stuff. The first thing is that in this presentation we will focus on Java, of course, and on the related technologies, but we'll not talk much about the unit testing and integration testing as a general term. We'll just focus on this subject like sprint test framework. So there will be no such best practices for testing in general. Just they will concern this spring test framework, and we'll talk about Spring 4 and JUnit 4, and there will be no Spring Boot in presentation, and of course, because there's already Spring 5 for some time, but the general concept actually doesn't change much or at all. There are some new features added, but mostly it is based on Spring 4 right now, this presentation. And okay, so why I would like to start this presentation at the beginning. So this is mostly because in projects which I take part, or in general, the developers, when they take part in the project, they usually are in some existing solution. So some testing and building approaches are already there. So if you're a new developer or not so experienced, you probably just usually work in copy-paste manner. So you see how it is done in some place, and you just try to do the same because it is more or less working. Yeah. So sorry, there's one question, and yeah, I think so. We can get the presentation after it is finished. So yeah, I think so. I will probably put it in the handouts. There is such box in this presentation. Okay. Anyway, yeah. Let's go back to presentation. So usually, what happens is that we don't focus too much on the testing. We usually just this is not really complicated. But if you write the unit testing or some other testing, you just create a method, annotate with test, and do the stuff. But in case of Spring, there could be a little bit more to set up, a little bit more to know about how it works and how it behaves. So if there is not enough time to gain the knowledge about the framework, you can end up with quite inconsistency in your code base about the test. And as we all know, the test should be as good as a production code. So it is good to know about a little bit more about the framework. Yeah, and yeah, so that's the base motivation for it. And besides that, the Spring test framework can work, alone. It also can be used with together with Mockito or some other testing tools. So the framework in general is agnostic, and so you can mix those tools to get the desirable results. So it is also nice to know when you can use it and why to use it. Of course, to make it the better decision to make when and how to use it, and it is always good to have a nice recap of all possibilities and try to work on that. Yeah. So okay, so unit testing and integration testing. So basically, maybe the definitions of that are, you can easily find them. But for me, the unit testing is always something which should be pretty fast, and it should not take you into account any other components in your system. So if you can, you should mock everything, and it should also concern only the small piece of code. So you should not try to test some big large portion of code with unit testing. If it happens that you need to create many mocks or take care of many dependencies, probably it means that the method which you are testing is not good written. So you can rethink it or redesign it, and this is why this testing is important, because actually it validates your design and your approach to the code. And in terms of integration testing, of course, we actually are more concerned about the big portion of code, so the communication between different components or between different layers. And usually where you have a Spring framework and you work on Spring, usually at least have you should probably at least have 3 layers. And if you're building the web application, for example, yes, so there at least should be like that. So integration test should take care of all these layers and to verify if all those components from different layers actually are working together. But of course, the integration also gives this possibility to verify if dependencies are correct, or if some properties are correct loaded and from correct paths, and so on and so on. But also in the integration test, we can mock some parts of the stuff. So if we have integrations with external system like databases, web services, or even FTP emails, or such things, we can always put some mocks somewhere around there to verify that logic which is on our side, not on the side of the external service. Yeah. So that's the way. That's why this integration and unit testing is important. Of course, if we are talking about Spring Test framework, we are more interested in integration testing, because unit testing can be done in many ways if you have services or some others components. Okay, so how the Spring actually can help you with both of types of testing. So of course, the first thing is to take care of dependency injection, and so in your test you can use dependency injection. You can inject your services to your test class, and Spring can take care of creating the application context and all the facilities which you are usually have in your normal application. Of course, if you have a clean architecture, I mean, clean, it is well and consistent designed, so you don't mix the connection between the different components. So something from one layer which is for example from data access layer is used in your MVC code or the view code, it is not good clean architecture, because you have those dependencies mixed, and then you can end up with a very bad test for that, because you have to include all the dependencies which are actually not needed, or you could mock otherwise. So it is also good that to keep to Spring architecture recommendation. So if you do that, it will also keep your test code much cleaner and easier to write. And there are also this Spring Test framework provides some mock objects and support classes, which we of course will talk about a little bit more later. But this usually means that you have access to some web context controllers and filters. They are bunch of mocks which we can use, and for other stuff. There are some general utilities and also mocks for Spring MVC, model and view assertions and checks. Okay, so more about Spring. So in general, the idea behind this Spring Test framework is to test your components, your layers, without need to deploy your application anywhere. So you can actually, you don't have to deploy your application to application container or some servlet container to verify the communication and to test your controllers, to test your services, to test your data access layer. So the idea is just to make it easier to run it locally on your computer and with some small portion of memory and CPU. As you can see, the general package structure, you can see the how it actually is created. So there are of course more packages for that, but when you have the Spring Test module added to your project, you have access to these packages, so you can go through them and check what is there. So there are a couple of packages which are used in different scenarios, like JDBC or web. And of course, there are some classes, some support classes and annotation and utilities classes which you can use, like reflection test utils, which could be useful if you have to change some constant or maybe some private field in your class under test. But of course, the thing is that if you use the reflection in your test to change something, probably it means that this is not what how it should look like, and probably you should just redesign your class or method. But of course, there are like places or situations where you actually need to do this, because you work on some with some third-party libraries, and so on. So it could be something which can be avoided. So it is good to know that you have this reflection test utils. The next thing is, the next thing is this AOP test utils, which is utility to get objects. If you create a bean and it is under a proxy, which Spring dynamically generates, these utilities will just give you access to this real class underneath it. So you can use it to, for example, if you have some mocks or you have to verify something on the class, you can use this utility to get access to this class and to verify something. The JDBC test utils is, of course, for access to database, so you can count rows in a table. You have just some couple of utilities methods which you can use, or you can just delete some records, or and so on, so on. And of course, it used the JDBC template to do that. So you need to have access to that. TestContext transaction utils. This is also connected with database, and if you have transactions, you can also use this to get some information about transactions. And the last thing, which is I think quite nice to have, is XML and JSON helper assertion expectation methods. And this actually helper classes give possibility to to make normal assertion on content on XML or JSON. So if your MVC controller returns, for example, some JSON stuff like some REST API, then you can use this to verify the content of the response from MVC. Yeah. Okay, so as I said before, most of the stuff is in the Spring Test module. So if you add this this to your project, you will get access to all the packages and all those classes and annotation. And the primary goals of Spring integration, besides that it helps you to test your Spring code, is actually that you have something like context management. So the typical application context, which is created every time when you start up your application. So the Spring Test framework takes care of this context management stuff. And there is one of the most important thing actually in this test framework is the caching of the context of the application context. So every time you run the test, the context is created. So if you have like 1,000 or 2,000 tests, it could be problematic that you create same context every time. Every time for each method, for each class, you create an application context for that. So if you have one application context which is not changed from test to test, it will be cached and it will be reused, and it will be reused for each other test which are run in the same test suite. And here it is worth to notice that in a Spring Test framework, the test suite is actually one process which run, or one JVM process which run all the tests. So when you run it from Gradle, Maven, or Ant, then there should be one process which runs all the tests, unless you enable some parallel execution, but then you will not have this caching mechanism, which is quite important here. So And the next is dependency injection. So as we talk about, this is mostly for the auto-wired annotation your test, or so when you start the test, you can get the beans from the application context, and you can use them to test them and yeah, to do anything. So also if you use mocks instead of real implementation in your test, when you create a bean which is mock, then you also has access to this, and you can auto-wire it to your test, and you can do some expectation on that, on verification with Mockito, for example. The next thing is transaction management, which is also quite important, because if you have if you want to test the database code, then you have to also take into account transactions, and this is actually quite easy done in Spring test framework, and we'll see some examples later on. Then we have those support classes and annotation for testing. So basically the Spring gives you two basic abstract classes which you can extend and use them in your test. They already have proper annotations, some configuration for test listeners and context, but this is not necessary. Like they are there, but you don't have to use them. You can use only the annotations, but they give you, for example, access to application context or to transactions in case of abstract transactional JUnit for Spring context test. So this is quite important to know, that you can extend this or use it, or maybe you would like to go with another way. Yeah, so that was the first introduction to all the stuff which is in test framework, and now we will see a little bit code. So I will switch to my code. Okay, so we start with very simple examples. So the difference when we use this abstract JUnit for Spring context test, and when we actually don't use it and create our own configuration in annotations. So this is two very basic examples. You can see that we have we have some service, book service, which we would like to test, and yeah, so this example shows how to actually create such simple tests and how to test your methods. And please note that the book service is rather simple. There is nothing special, and the method, the implementation also is not very special. And this is only because we don't care about it. We want to see what happens on Spring TestContext framework, not how to actually test, do the testing in general. Okay, so one more thing about this. So we start with this annotation based stuff. So to start, you have two options. You need to use the Spring JUnit for class runner, or you can use the Spring runner. They have, like, this is the same. This is just shorter, so you can use this or this. There is no matter which. And then you have something which is called context configuration, which actually tells how to create application context for this test. We'll talk about the context and context management a little bit later. And as you can see, it uses the classes attribute to load some configuration. And in service config class, which is a typical Spring configuration class, we define this book service bin. And then next we use AutoWire to actually get this book service bin. So when we start this test, this bin is injected into our test by Spring Test Framework. And then there's a typical test method where we have some data, we execute our code, and then we assert the results. So this setup will actually create the bin with implementation, inject it into our test, and then we can use it in our test. So there could be many tests for it, as much as you want. So let's start it. Yeah, so it was hidden. Okay, so as you can see, the test passed. That's fine. But something which is more important here is the information which we have from the Spring test. I add some logging categories to get some information. So in this case, this red one are from Spring Test Framework. So we can just see when it's the code executed from Spring Test Framework is executed. But we will talk about it a little bit more later, what we see there and so on. And the second example is pretty much the same. Like it has the same stuff. The difference is that we actually extend abstract JUnit for Spring context test, which is in fact very similar to what we have previous, but it actually uses Spring Runner, defines some test execution, but it also has application context, which we have then access to in our test code. So when we start this, Spring automatically create this application context in our class, and then we can get the bins in typical way where we have this application context, and the rest of the test is the same. So we can run it, and we pass our test. The only thing which is important here is that if we have auto-wired, the bin is taken before the test, and if we have this approach, the bin is created and put in the test in this place, not before the test. And of course, you can, in the same way, you can actually you still can use the auto-wire to have the same behavior. You don't have to use this application context if you actually don't want to. You can still use auto-wired. So yeah, so you can mix a little bit in this way. Okay, that was the warm-up for the code. We'll back to the presentation. Yep. Okay. Okay, so now we will talk a little bit more how the framework actually works. So we will start with the key classes to the framework, like TestContext, TestContext Manager, text loaders, and test execution listeners. And then we talk about a little bit context management and configuration, about the caching mechanism and transaction management, and the support for Spring MVC. And you also must remember that, as in any place in Spring, the test context framework places a great deal of importance on convention over configuration. So there are some defaults, and yeah, you can use them to work with your code. Okay, so the test context and test context manager. So the test context encapsulates the context, and it actually provides the management of the context and the caching for the context. So actually, if we load the context, it is done through this test context class, but it actually delegates this context loading to what is called the smart context loader, so we can use different sources of context information like XML, Java annotation classes, and Groovy way of configuring the Spring. So the smart context gives you these possibilities, and test context actually delegates the loading of the context to this class, and it also governs the caching of the application context. Test Context Manager is the main entry point to the Spring Test Context Framework, and it mostly is used to signals the events to test execution listeners. So you have different events before the class, and all methods in testing are executed after, and so on. So you can take part in this process. You can add your own test execution listeners just to have more some more ways to modify maybe something, or maybe to do some actions when there are some certain conditions, for example, on maybe profile, maybe the operating system, and so on. So the test context manager actually signals all those events, and they can be then consumed by test execution listeners. And the test execution listeners, as we said, defines the API for reacting on different events. So for example, there are a couple of already defined listeners, which are by default loaded for each test. So the one which, for example, the dependency injection list test execution listener is responsible to check your class for auto-wired annotation and to actually inject the test classes to your test. So you can see that you can actually do something useful with those listeners, and they are added by default, those 6 here. Of course, this transactional test execution listener is added when you use the database stuff. The same for SQL script test execution listener. And yeah, and the default default list of those listeners are in Spring Factories file. This is some standard way of Spring to define some of its configuration. It's usually in meta inf folder, and then you can find the Spring Factories, and then there is the list of this default stuff. Of course, you can register your custom filters. You can add them, and for this is the test execution listener annotation. And The thing which is worth to noting is that they have specific ordering there, and they use the concept of order annotation or ordered interface in Spring. This is some common way in Spring to give Spring information how some beans should be processed in what order or executed in what order. So in this way, you can define where your test execution listener should be executed. So each of these default execution listeners have this order, and they have like well-defined place when they are executed. So you have to take this into account when you create your custom filter, custom test listener, to put it in a proper place whenever you want to be at the beginning, at the end, and so on. So the order is not derived from appearance in the code or whenever, but by this order annotation or ordered interface. And one more thing, when you use the test execution listeners and you put your listener there, it will like get rid of all default listeners. So what you have to remember, you have to add this merge mode attribute to test execution listener just to and put it to merge with default. So your test listener will be added to the defaults one, and you will have all the setup for that. Okay, so the context management. So as you saw in the example, we have different ways of actually defining this context, or maybe to keep this stuff related to application context and web application context. And web application context is when you use this web app configuration, this one, and you can use either the support class, or you can use the context configuration when run with, which gives you access to application context either through auto-wired, or you will just have a variable which is already there. And okay, so and as we saw before, context configuration have this classes attribute, which gives us possibility to define which configuration from your application or from your project actually should be added to the test context. There are also the context initializers. You can use them. This is a little bit more advanced topic, so we'll not talk here too much about it. But you can also have there are a couple of places where you actually can modify the behavior of test framework context. And then we have this inherit stuff. It is actually used in many places, in many annotations, but basically inherit locations means that if we have a class hierarchy of context, whenever we want to inherit the context from the parent class, and I will show you example in a minute. And Spring test framework also has support for active profiles and profile annotations, especially the profile annotation, and which gives you possibility to use the configuration for given profile. So if you have some production configuration, if you have some local configuration, you can use this profile to use them, and it could be quite useful in your applications that for the test you have different profiles, so you can have a configuration which have some mocks, and instead of using some real code, you can use this mocked version of configuration for database or for some external services. So it could be very useful. And one thing, of course, they have also this inherit stuff, so you can use whenever you want to inherit profiles from the parent class or not, and so on. The next thing is the test property source. This is quite important because normally in Spring you have annotation which is property source, and you can add properties with annotation to your environment, and then you can use those properties in your code. And the very important thing about the test property source is that actually it has highest precedence. So you can, even if you have defined in your config classes for your production code some property source, and if you define in your test class this test property source, it will override all the properties from the original one. Of course, you don't have to override everything. You can just choose selectively choose which properties to override. So you can load some properties from file for test purposes, and only override which you want. And of course, they have these inherit locations and inherit properties. And there's also one nice annotation with attribute in annotation, which is properties, where you can define in the code the properties which you would like to override. So you don't need the file to actually to override something. Yeah. So contents management and context hierarchies. So in Spring, you have context hierarchy, and it is related to tests. So you can have like parent context and child context. For example, when you have Spring MVC or Spring Batch, you can use these context hierarchies to, for example, load as a parent context. You can load some shared classes or beans, and for each, for example, in Spring Batch, for each batch job, you can load the child context with only configuration for this particular bean. So it it actually can be quite useful to not to load everything in one time. And of course, we have these inherit locations we can use to override something from the parent class. And then this context will go back to this later on, and in the next slide. And the next thing is actually this caching and how it works. So as I said, the caching is quite important concept in this test framework. And it means that every time when you have a class and when you have this annotation with context configuration, the framework will try to create the application for context for your test. But to make it easier and faster, it creates the unique, let's say, key, which it stores already loaded application context. And if this key, is already in the cache, it actually used the context from the cache, and the context is not loaded again. To build this key, there are a couple of different things taken into account. So, for example, from annotation context configuration, the classes and locations. The classes are for Java-based configuration, and locations for XML-based configurations. active profiles. So if you have different profiles on different classes, then the key will be different. So this is also quite important. Of course, there are a couple of others like context initializer classes. Actually, everything which somehow can change your application context must be taken into account, just to be sure that we have all the bins in place when we use something from the cache. The same for properties, because the properties can actually change your application context. And as I said before, we have in Spring Word, the test suite actually means that all tests are run in the same JVM. So if you use something which makes several processes to run your tests, this caching mechanism will be not used properly, or will not give you anything. So it is good to remember that you should use one JVM to run your tests. Yeah. There are two things which you can do to make some debugging or to change behavior of the cache. So the cache by default have 32 size. So if there is more contexts than this number, they will be just removed. The least recently used will be removed, and it will be recreated again if some test class will use it. So it is good to know that there is such parameter, and you can enable this debug on the cache just to see that we what is the contents of the cache, and what other things can be wrong. And the one thing about caching is this dirtiest context. It is quite important because actually to change behavior of the cache. So if for some reason your test method will change something in the bin state, or you think that the cache the context should be recreated, you can use this annotation on the class or method level, dirtiest context, and then it means that it will recreate the cache. And depending on method mode and class mode, and as we saw before, there is hierarchy mode attribute, it will do it different stages of the test execution. So it could be after the test class, it could be after test method, or before test method. So there are a couple of ways to do it. And it could be useful when you, for example, have a database test which change the database for some reason, and you can't use this Spring support for this, and it really changes your database, and your test requires that it changes in some way too, and you have to verify it. Okay, so now I will show you a couple of tests for context. Let me just move to okay, so here you can see the basic maybe not the basic, but the class which have a couple of changes related to TestExecutionListener, and and to the context. So it is the same as before. The one thing is that I add my custom TestExecutionListener, and as I told you before, I use this merge with defaults. And also I have couple of Spring annotation from JUnit, annotation from JUnit, just to see where the Spring test execution listener is executed, and where executed are our classes from JUnit with respect to that, so we can take proper action. So if you run this, you can just look at your logs and see the red one is from test framework, and other stuff is from other parts of Spring, which is not so important. But as you can see, you have environment TestExecutionListener here. So it is executed before test class, and then we have our test before class method. So this Spring stuff usually goes before, and then we have some prepare and so on. Before test method is on execution test listener. So as you can see, you can do some stuff before test method, and then there is the real execution. The one more thing which it is worth to notice here is that is this information, which tells you that the application context is retrieved from the cache with this key. So you can see that all parameters which are used to create this application context, and it is stored under this key. And also this information is important because it shows you the cache size, the max size, and some other cache statistics. So if you have some problems, you can look at this log statistics and see what actually you have in the cache, and what to do with it. And yeah, so I will just quickly go to the environment test execution listener, which we have here. It has a couple of methods, as you can see, and in here actually what I did is that I register before test class, I register dynamic component, which is just normal Spring component, and it is added as a dependency to this test. And then in this context test, I actually use this dynamic component, and as you can see, it is not defined in this configuration. So in this environment test execution listener, I actually add dynamically bin, which I can then test here. And one more thing about the test context. As I said, as long as the everything works in the GVM, one GVM, there should be one context in the cache, so we can try and run those three tests and see the cache at the end. The cache statistic is that it is still size 1. So we execute all those three tests, and there was only one cache, only one application context created for it. But of course, with this test execution listener, we cheat a little bit because we added dynamically a bin. So actually the application context is changed in some place. So you must be aware of that Spring rather will not see that because it is added dynamically to the code. And one interesting thing about the context configuration, if you don't specify any configuration here, no classes or anything, you can specify the nested class config, which is configurations. It should be static and has this annotation. And Spring will automatically pick up this configuration for you, and you can use it to test it. So if you have some small, or if you have some requirements, you can just create this context in this way. And another thing about the hierarchies, about context, class hierarchies and the context, this, here you can see that we have this abstract class context hierarchy, and you can run, there's normal configuration, but if you extend this class and add the stuff here, the context will be merged. Both contexts will be merged. So so you should actually end up with one application context, even though you actually you have two context configuration. But if you extend some class with context configuration, it will be just merged together, and one context will be created. You can use this inherit location to false to create separate or to not inherit the context configuration from here, which actually means that you will still have one context, but only with this configuration, not what is defined in this abstract class. Yeah, and the property, as I said, we have this test property source, and the common config has the property source, which defines some properties for this common component, which are loaded with value add notation. And but for this test, you can just override in this manner the value for application name, because it comes from here, right? So application name is TechTalk, type is TechTalk, but here we just override it, and this method actually will give us TechTalk test, not the TechTalk alone. So all the test goes okay. Okay, let's go back to presentation. Okay. Yeah, so transaction management, you have a new listener for that. This is transactional test execution listener. And you have a very interesting class, which is called test transaction, which you actually can use to control the transactions inside the test method. It could be useful sometimes, but in general, you should use only this transaction test execution listener. It is important that if you have test which requires transaction, you have to define somewhere the platform transaction manager, just to support this transaction as the usual configuration in Spring. Also, you have to remember what is test managed transaction, Spring managed transaction, application managed transaction. So in general, test managed transactions are transactions created for the test method, which Spring managed transaction or application managed transaction actually should take part in. So your Spring code for transactions should usually take part in the transaction which is created by test method. So, and the application transaction is like more the transactions which are done manually in the code. So if you don't use the Spring annotation, like transaction annotation, then you and you create the transaction by hand, you also have to remember that running the test with transactional support, the transaction created by you in the code should, take part in this transaction. We have rollback behavior by default. So each test method after it is executed rollbacks to state before. So if you don't use test transaction class which can commit stuff in the method, the default behavior is to roll back all the changes which you done in the test code. Of course, you can change that using the commit and rollback annotations. So you can use both those approaches just to tell the test how to behave. You have before and after transaction annotation, which can help you to verify the state of the database and to see what is going on. Abstract transactional JUnit for Spring Context, it gives you the same things as the other abstract class which we used before, but with transactional support. So you can use some database related methods. The very important thing is the when you use the JPA or Hibernate or similar frameworks, they usually keep stuff in some session or something like that. So they usually move everything to the database where you commit the transaction. So when you do the test, you must remember to flash the state of the session for Hibernate before you actually do any assertion on database. Otherwise, everything is happening on in memory. So until it is flashed and executed on database, you cannot actually make assertion on the any database state. So you must to remember to flash that before you do assertion. There is also possibility to initialize the database and execute SQL scripts with script utils or resource database populator, but I will skip this. But there is some couple of annotation which you can use, or you can use this resource database populator to do that. And of course, we will now move to the example. Okay, so here is some general test method or test class which have everything in it. So I will just go through it just to tell you what is going on. First of all, of course, there is a database config, which has this JDBC and transaction manager stuff, which I talked about before. And it has two configs for data sources. One is dev, with profile dev, with some test data and bootstrap, and prod data source, which has profile prod, which only has the bootstrap stuff. So the difference is that the bootstrap creates the table and test data creates some records in it. And we'll see how it is used in a minute. So we have this database configuration. This is typical context configuration. We said we want to use the active profile. So the profile for dev, which creates the database and loads the database with some data. We add this transactional to set that all the methods are transactional. And here, in general, if it is not it is commented, the default behavior is rollback. but here, sorry, so here we force that the default behavior is commit after each method, just to show you the example. So then we use this before transaction method to verify that we have two customers, and after transaction that to verify we still have two customers, even though we have two tests. And here there is a rollback, which means that after this method, so after we execute insert, we actually roll back this operation. But in the test method, we can check the count of customers, and we'll see that it is 3, not 2, as it is done by default, right? So yeah, so the test pass on this assertion. And here is a little bit tricky because I use the test transaction. It still has the rollback stuff, but before this, because this method is executed and there is a transaction started when it is executed, we in the middle we said, okay, we would like to commit it and end the transaction, and then we can verify that transaction is not active and that number of rows is free. And then we start another transaction and insert the stuff, which technically should give us 4 rows, but actually it gives us 3 rows because we have this rollback here. So this transaction which we start here actually is rolled back. So of course it fails because it is failing on this after final database state. So it is 3 instead of 2, which we expect because it destroys because it do the commit, right? And the one thing to notice here is also that you have this TestContext, which can be used here, because if we would like to run those tests together, okay, maybe another way. Let's uncomment this. If we run this test together, they both fails because this test already changes something and it is executed first. So it changes the state of the database. So this doesn't hold anymore. But if you use this TestContext, we said that the context must be reloaded. So the Spring reloads the context and the database, of course, because this is the in-memory database. So this method get the clear database state after this method is executed. So in this way, you can use this TestContext. Okay, let's go back to the presentation. Okay, so yeah, so I will not talk much about here because this is just a reference. We talk almost about all the annotations here. The SQL config and SQL group is just the way you can bootstrap your database with some data. Instead of using the way I did it in data source, you can add this annotation to the test class and just to set that you want to execute some scripts, SQL scripts before. And the bootstrap with is something which is used to configure actually your test framework. You can change the text context creation, text manager, and text listener, and there are a couple of things you can actually change if you really need to. Standard annotation and JUnit annotation support. So as we talked before, the auto-wired, qualifier, transactional, this is the standard things which are supported. Also some JUnit things like if profile value or time or repeat annotation can be used to do some additional stuff. one thing to remember is that you can all the annotation from Springs are have the meta annotation support, so you can, if you have some common configuration of annotations, you can create your own annotation and group them together and have your own stuff there. Run with we talked about already, and the Spring class rule and Spring method rule. So for example, if you can't use the run with annotation because for example you are using Mockito, then you can add this JUnit rules, both of them, so you have the Spring support in your test anyway, even though you use the Mockito. Okay, so can we mix different frameworks and libraries? Yes, we can. So Mockito works well with Spring Test Framework. You can mocks the bin either with the mock method or mock annotation. You can mix the inject and inject mocks and so on. And in general, if you use the Mockito, you can use the Mockito JUnit runner. Okay, and the last thing actually in this presentation, I think, is the MVC component. And I will just give you an example and don't talk much about this presentation. The point is that the Spring gives you all the web component related things like filter chain, session, servlet context. There are some mocks which are used in this testing MVC, so you can verify on them and you can use them. There is what is called standalone and application context setup. So you can test either controller alone without the whole Spring stuff which is there, or you can actually load the web application context and have a better testing support. It also includes the Fluent API, so you can do the request to your controllers, checks the response, and so on. And before, well, when you actually initialize the web context, you can add filters to it. You can add view resolvers and some other stuff just to test different aspects of your view layer, let's say. And of course, there is some integration with other frameworks which can help you to validate the responses from the Spring, like HTML unit or similar. Okay, so let's go to the code. So first, maybe the Spring and Mockito stuff. So here we have a very simple configuration. I use this inner or nested class, but you can see, for example, I can create the context with some mocks instead of real objects, and I can use then those mocks to create service which I would like to test. So this component service is dependent on those two components, and we would like to say that this is the mock version and this is the real implementation, and then we actually use this component service to do some testing on it. And as you can see, we can then auto-wire both stuff. This will be mocked, and we can use Mockito to just force that instead of default value, we actually return something else. and in case of this, the second, the static component, we just use it normally. So yeah, so as you can see, the test passed, and that we can actually do such a thing. And the Mockito example is very similar, except that we use the Mockito JUnit runner, and we do the similar thing. So for the mock stuff, we use the mock, and for the real implementation, you can use SPY, which is also kind of a mock, but it used the real methods instead of just returns null or do nothing. And yeah, the code is the same, so we can do pretty much the same. And then to create the object, which is very important, we have to use the implementation here version. We just inject mocks, and the Mockito will just inject those two defined things. So as you can see, you can use the Mockito in these two ways. So either you can use Mockito JUnit runner and just use the components in this way, or you can just use the Spring and you can mock some of the beans in this way. And okay, so then we have MVC example. So first one is the web app context setup, where we actually use this web app configuration, which is needed to create web context, and we use context configuration to load backend part of some service and frontend for controller. And here you can see that we have controller which would like to test, so it uses this greeting service to say hello to some parameter to the name. So whenever it is, it will say hello to it and put this in the model, which is then rendered by some template, which will just create the HTML with span with this greeting, which actually this service is giving us. So here you can see that first we have to create this mock MVC with our application context. So it will create application context with this configuration. We are building it, and then with web mock MVC, we can use this Fluent API to perform the get HTTP method for our URL, put a parameter as a John, and then we can verify that we expect that the status is okay, and the content is content type is of this type, and that we actually can find with XPath the tag span, which has this value, hello John, because this is what actually this greeting is doing, right? So it just prints the hello in the name. So we can see that it actually runs. Yeah, and the other way of testing the MVC is with this standalone setup. It's a little bit worse if we have this views here. We need to add some more setup to it, but we actually are using only we only use this one controller, so we don't load everything. We just use this controller, and we can mock the greetings service if you would like. And then actually we don't check what is generated by this standalone, because this is the one thing which actually is not done when we use the standalone setup. So it is faster, but it doesn't give you all the things which are actually done by Spring when you do the real call to your controllers, to your endpoints. So of course it will just go through. So the only thing which we can get is the view which is generated by home controller. So we know that it passes because the view was returned by this controller. Okay, and the last thing which I would like to show you is that if we have this configuration, context configuration, as you saw before here, we have backend config and frontend config, but we also can use the production config frontend, but for backend we can actually use mocked. So we use Mockito just to create mock for greeting service, the same as for standalone. And then instead of so then instead of so then we actually force that it will always, this greeting service, whenever we put the name here, we actually return hi John every time, because and then we can verify that this is actually executed, this one method say hello to. And yeah, so if we want to only check the controllers, we don't want to check any other layer which is beneath, we can just create the mocks for it, and it will only check the one layer in your application, in your test. So you don't need to load anything else, only the controllers, and everything could be cut off. All the other layers could be cut off with this configuration. Okay. Okay, so basically that's all. Just to sum up, this what we talk about. So we talk about the Spring Test framework. We focus on some key concepts like caching, context management, and go through annotations which are, and support classes which are should be used in your tests. And also we have a couple of examples to show how this framework actually works. So if you want to find any more information, probably the best way is to check the Spring Framework docs, because these docs are pretty cool and very good. And also you probably should go to Java docs, consult Java docs, and read the information there, because you can also find many interesting many interesting stuff there. So that's the end.